Many players complain that GTO is needlessly complicated and too hard to learn. Today, we put that claim to the test. We're going to solve 5 different c-betting strategies with various levels of complexity, from galaxy brain to Braindead, and measure the EV loss along the way. Just how simple can you make your strategy before the solver rips it apart? Let's find out. One spot, 5 strategies. In this video, we'll benchmark a cutoff versus big blind single raise pot using 5 different c-betting strategies, increasing in simplicity. Along each step, we'll measure the EV loss using customized aggregate reports, and I'll show you how to use this tool so that you can create your own simplifications. The very first spot is the most complex strategy, which are very similar to our general solution. So it's a complicated 4-sizing split across all flops. Let me show you what that looks like. Here's the spot. Cutoff opens, big blind calls, the flop is anything, check, action on cutoff, and here you can see a very complicated 4-sizing split. These were among the first solutions published to GTO Wizard, and the reason it's using 4 different sizings is because, well, we didn't know what would be best. So we might as well just publish the least exploitable strategy that we can produce, which in this case was the quote-unquote general solutions. But admittedly, having all these different bet sizes is pretty hard to learn. And so this is going to represent our galaxy brain ultra complex strategy. I still think this is superhuman. This is far beyond what any human can actually implement in practice. So let's simplify it. Now I'm going to click AI solve. And in here, we can choose between 3 different types of betting structures: automatic, dynamic, and fixed. Now, automatic and dynamic are essentially going to choose 1 or 2 bet sizes at each node from a list you specify. A fixed strategy, on the other hand, is like what we just saw. You give it all the different sizes and it's going to mix how it chooses. So instead of giving it this complicated strategy, I'm going to load up a much simpler strategy that I've built, which is this dynamic 2-sizing one. Now, what this one says is we're going to choose between these bet sizes, and I want you to choose 1 bet. So we're either going to c-bet 25% or 75%, and nothing else. So if it on certain flops, it'll be 25, on other flops, it'll be 75, but it's never going to mix between these 2 sizes. This is how most pros are currently simplifying their strategy. They have like a small bet, they have a big bet size and a small bet size, and then they say certain flops belong to the small betting size, certain flops belong to the big betting size, and those 2 don't mix, okay? And I've tried to give big blind a fairly complicated counter strategy just to be able to punish any weaknesses we might have. So this will be our first test, our first simplification, is how much does a dynamic strategy lose? For example, on 8-3 deuce, I can see that the cutoff prefers a 75% pot size bet. However, if I were to change the spot, let's say 8-3-3, I could see that the cutoff prefers a 25% pot size bet. And in general, it's going to choose between any of the sizes I give it. And I can give it more sizes or fewer sizes. But I think even this very simple 2-sizing strategy is more than enough. Here's the problem though. I don't just want to bench this on 8-3-3. I want to bench it across all possible flops. To do that, I'm going to hit reports over here. Now I'll see a pop-up. The pop-up shows me how much the report costs. The cost is in power credits, an in-app currency you can purchase. In general, the more complicated the spot, the more it's going to cost. So if you want to try and reduce cost, just cut out some of the needless donk bet sizes that you're probably not using anyway. That's going to bring the cost down. I'll go ahead and generate a new report. And here's what that report looks like. So now you can see that on every flop, I'm either going to bet 25 or 75. You can see some flops are big bets, and some flops are small bets. And using this method, it's actually very easy to split your strategy into these 2 different sizes. So here I've sorted for the 75% quote-unquote big bet sizes, and here I'll sort for the small bet sizes. Perhaps another way is to use grouping. For example, I can group by high card, and I'm just going to sort that from ace downwards. And you can see that For example, Jack high, 10 high, and Queen high flops are the most preferred for large sizes, whereas these ones with lower cards tend to use the smaller sizes. We could also, for example, try grouping it by suit. And as you could see, for example, monotone flops always preferring the small size and so on. Now, I already have a video that covers how to dig into an aggregate report. That's not what this video is really about. This video is more about measuring the performance. So how do we see the performance of this simplification? Well, for example, if you take a look at table here, you can see the expected value, each player here and here. Now, right now I have that shown as a percentage of the pot. Alternatively, I can press Shift and Space and display that in big blinds. Now, here's the key point. Whenever you're comparing EV between different strategies, compare at the root node. That is to say, the very first decision point. And the reason is, after big blind checks, they've changed their range sometimes. Like, sometimes they're going to lead out. And so the very act of them checking changes your expected value. So for a fair apples to apples comparison, always compare EV at the very first decision point on that street. Okay, so here we can see each player's expected value here and here. And we're going to go ahead and write this down and compare some other strategies. Now, I'm going to go back to my complicated Galaxy Brain strategy. I'm actually going to solve that with AI and run a complicated report on it. And the reason is that I want it to be solved with the same technology that I'm using for dynamic sizing and all the other simplifications. That way we get a really fair apples to apples comparison. So I've done my best to recreate the exact same betting tree in GTO Wizard here. And I'm going to go ahead and create this report. And here's what it looks like. You can see that different flops are mixing different sizes. So instead of having, let's say, one size for each flop, it's going to mix all of these different sizes. Going back to the root node, we can observe the expected value here and write that down. There's this famous Adam Savage quote that goes, "Remember, kids, the only difference between screwing around and science is writing it down." And I don't know, this quote just tickles me. It's so ridiculously true, though. So that's what we're going to do. We're just going to write some stuff down and see what happens. So at the very top, I've got our complicated force sizing strategy, and you can see that cutoff has 2.98 EV. And then we tried our dynamic strategy, where we're only having one bet size per flop instead of trying to mix 4 different sizes. And you can see that our EV doesn't really change at all. In fact, it's the same. Cutoff big line maybe gains like a tiny fraction, but for all intents and purposes, this dynamic strategy is just as good as this complex strategy. Okay, so if only using one size per flop didn't really change our EV at all, what if we make it even more simple? Okay, so if splitting 2 different sizes barely made a difference, then what if we only have one size? What if we only bet 33 or check? Right? Like, do we actually need to split big sizes on some textures, small on other textures? Let's find out. Let's just bench it, right? And here it is in all its simple glory. As you can see, the cutoff only has the choice to bet 33 on every single flop. Not exactly a very complicated strategy. The only thing you really have to learn is like when you're doing a lot of betting and when you're doing a lot of checking. It's not exactly a difficult strategy to implement, but how does it perform? Well, again, we're going to go to the root node, ding, and we're going to measure the EVs right here, 1.73, 2.97, add that to our magic table. And yeah, it basically doesn't matter at all. So do you need a complicated split sizing strategy? I'm not so sure. I mean, B33 seems to be sufficient in this spot anyway. As you can see, the cutoff's EV went from 2.98 to 2.97. But like, this is within the margin of error. Like, I'm not even sure like our accuracy is high enough to measure a big blind per 100 difference this small. Do you know what I'm saying? Like, maybe, yeah, maybe there's some exploitable difference, or maybe this is just within the margins of what we can even reasonably measure using this technology. So, yeah, conclusion, simple still keeps basically all of your EV. So, if that's still good, how much dumber can we make our strategy? I present to you the PLO. We're going to be potting every single flop and facing a raise. We're still going to be potting, so there's no nuance whatsoever. We have one bet size, and it is pot. Okay, let's see how this one does. Here's the setup. As you can see, bet, pot, raise, pot, re-raise, pot. Absolutely no nuance whatsoever with our strategy. Now, I've kept the big blind super complex to try and take advantage of our simplifications, but let's just see how it does. All right, now first of all, what does this strategy look like? Well, turns out that when you bet 100% pot, you don't get to bet that often. So that's why we're checking back 62% of the time here. But when you do get to pot, well, you get to be pretty aggressive about it. Okay, so how much EV does this strategy lose? Again, we're going to go back to the root node. And we're going to take a look here. And you know what, I'm just going to switch that back over to big blinds. And finally, we can see the expected value of each player at the root node. Let's go ahead and add that to our table. And here we have it. And as you can see, our strategy is still retaining a ton of EV. Part of that is helped by the fact the rake is a little bit lower when we check back a lot. So at this point, we've lost a tiny bit of EV relative to the complex strategy, but it's only about 2 big blinds per 100 at this point. So yeah, as it turns out, you can make your c-betting strategy pretty darn simple without losing much, if any, EV. So some of you might be wondering how I'm computing the rake. It's actually really easy. You see, there's a rule in poker that the sum of everyone's expected value has to add to the pot. I know the pot is 5.1, and therefore I just go 5.1 minus big blind EV minus cutoff EV, and that gives me the rake. Real simple math. Finally, we talk about range betting, the London system of poker. This is a system where you just bet every single hand on every single flop for 33% of the pot. You don't have to think, you just have to click bet. It's very, very easy. So how much EV does range betting every flop actually lose in this formation? And here we are, the range bet. So every flop is betting everything all the time. And it's actually kind of fun to just go and see just how aggressive the big blind is supposed to try and counter this strategy. You can see that even though we're like, betting everything, they still have to overfold, which is kind of funny, like relative to MDF, I mean. But they have to counter us by being hella aggressive, like 25, 24% of the time they're raising. Yeah, it's actually like pretty hard to counter a range bet unless you've, like, without studying it, especially in spots that shouldn't be range bet. Anyway, let's go back to the root node and take a look at the EVs, 1.76 and 2.92. So finally, we start to see some proper EV losses. Adding it to our table here, that completes our 5 different levels of complexity. And as you can see, range betting didn't even cost that much EV. Perhaps it's easier to view these numbers if we change it over to measure the EV losses in big blinds per 100 relative to our complex reference point. And so you can see the dynamic strategy effectively lost nothing. It's equally as good. The simple strategy, where we're mixing B33 and check, loses, let's say, half a big blind per 100. The PLO strategy, where we bet 100 or check, and also bet 100 with all of our raises as well, this one lost 2 big blinds per 100, and then the range bet, which is like the simplest possible strategy we can implement, loses 6 big blinds per 100. Okay, so what's the best strategy? Well, if you're trying to find the best trade-off between simplicity and EV loss, a range bet wins by a landslide. It's not even remotely close. The amount of complexity you cut out of your strategy with a range bet is enormous, orders of magnitude above the rest, for really not that much EV loss, if you think about it. But there are practical reasons why players might prefer a more complicated strategy regardless. For one thing, easier for you also means easier for them. Another thing is that maybe this is the wrong goal. Like, the theoretical exploitability of some strategy does not equate to its real world EV loss. And the reason for that is your opponents aren't going to max exploit you, right? Like, just because the solver is showing 6 big blinds per 100 lower doesn't mean like you're going to have a win rate that's 6 big blinds per 100 lower in practice. What matters in reality is follow through, not flop sizing. So like, sure, you can implement a Rangebet, but how well can you follow through on turn and river? And in fact, you could implement a 2-sizing dynamic strategy. What matters is how well you can follow through with that strategy on later streets, or even like facing a check raise, as an example. Something else to consider is that when you try and ham-fist everything into one size, sometimes that's going to make your future street strategy more complicated, because there are some hands that play better or play more naturally as larger bets, and some hands that play better as smaller bets. Finally, consider the fact that it's not just about offense, you also have to consider defense. Your opponents don't necessarily care what sims you've solved in GTO Wizard. They're going to bet the sizes they prefer. And if you haven't studied those, you're going to be at a disadvantage. So there are real practical reasons to choose a more complex strategy, despite the fact that a simplified strategy doesn't actually cost much EV. All right, that's my video, guys. I'm going to leave a link so you can learn more about custom aggregate reports in the description. It's a really wonderful tool. You can learn so much from it. Let me know what interesting simplifications you find along the way. And as always, happy grinding.